So we look at similar triangles here, and we can see that these two triangles are similar. As long as you've got these two baselines parallel, which we will try and make them right now. If I can turn this around, you see, as long as it's parallel, this will be similar triangles. So we've got that this angle is obviously common to both, and we know that this angle here equals this one here, and obviously this one, I'll put 3 stripes on it, equals this one. So we were to say that this side here was 1, and this length here was 1, i.e. from here to here, and this was say 2, and therefore this would be 2. So we can say the ratio of the triangles, the lengths, ratio of lengths would be 1 to 2. Now why is it 1 to 2? Well, if you look at the big triangle, the length here of this whole distance is actually 2 units. The 1 plus the 1, and that's why the ratio is 1 this one to this one, 2 here, 1 to 2. So therefore, if we were to say that this length here was 3, therefore this length, the bottom length here, would be 6, because the ratio would be maintained as 1 to 2. Interestingly enough, the ratio of the two areas of the two triangles, so now if I was to draw the two triangles separately, I'll do them in not quite as big. So you've got one triangle there and one triangle there. The ratio of the areas is actually 1 to 4. You square the numbers. So ratio of areas equals 1 squared to 2 squared, which in this case will be 1 to 4. So the area of this was 8 centimeters squared. This would be 4 times as big, 32 centimeters squared. And it's easily proven because we draw a triangle here that is parallel to this side over here, and we draw a triangle, a line this way, which is parallel to this line here, then we get 3 equal triangles here of equal length, of equal area, and therefore 4 equal triangles. So by the same instance, if this was 1 here and this was 3, the ratio of the lengths would equal 1 to 4, because the 4 would come from the 1 plus 3. So therefore, if this was x and this was 3x plus 1, we could now make an equation that the x divided by 3x plus 1 would equal the ratio 1 to 4, small triangle to big triangle. Cross multiply, we get 4x equals 3x plus 1. Subtract the 3x to the other side, and 1x equals 1. So therefore the two lengths would be 1 and 4. This would be equal to 1 because x was 1. This would be 3 times 1 plus 1 is 4. So 1, 4. So questions 1, 2 and 3 here, try them on your own. Question 1 is exactly as we've seen it before, trying to find the value of x. Question 2, the small triangle is not quite the same as what we've seen, so you need to flip the small triangle over and it will fit nicely in with the two baselines being parallel as it is in question 1. Question 3, you'll have to rotate the top triangle down, and therefore we can find out x and y with the two similar triangles. The answers are at the back. So for right triangles now, we know that the ratios are all in some sort of harmony. If we take this angle here, at the bottom here, we know that this is the opposite side, this is the adjacent side, and this is the hypotenuse. This is review here. So if we call this angle theta, we know that tan theta has a ratio of the opposite side divided by the adjacent side. The sine of theta equals the opposite side divided by the hypotenuse, and the cos of theta equals the adjacent divided by the hypotenuse. So all these ratios will work as long as we've got this right angle in here. So let's have a look at a couple of questions now. So the question here to find x and y. We're given 23 degrees and 10. We know it's a right triangle, so we can straight away say that tan 23 equals x divided by 10. And if we take this 10 up and multiply, because we've got opposite over adjacent, so therefore x will be equal to 10 times tan 23. And if you get your calculator out, you can work that out to be 4.24. We now try and work out y. We know that cos 23 equals 10 over y, and therefore just swapping these two over, we get that y equals 10 divided by cos 23, and therefore y equals 10.86. Of course, we could work out the other angle easily by subtracting 90 minus 23, but if we do it by ratios, we know that, let's call this theta here. We know that tan of theta equals 10 divided by x, just in case we want to do it by the long way, of course. X we know is 4.24, and this is going to be a very rough estimate. So theta will be tan negative 1 on your calculator of 10 over 4.24. Don't know why I put equal sign there, but anyway. And that equals 67.02 degrees. So you can see there is some error there because the answer should be 67 exactly. Because we've rounded this answer of x here to 2 decimal places, we've got this error, which is like a 2% error. Interesting. So 2 questions here. We've got question 1 at the top there, where you've got to find x, y, and then angle theta, just working your way through the 2 triangles. Down the bottom here, interesting little question, we've got to find h, and we've got 2 right triangles. And of course, what you've got to introduce is a second variable here, which we'll call this length here, which you can call this length x. And of course, you've got a triangle here with a small triangle with x and h, and you've got a bigger triangle with the 15 degrees with 7 plus x and h, and you make 2 equations. We'll get the answers to those at the back of the page.
I'll be there in a minute.